We are going to see one of the interesting lecture. We'll reflect a point in a general line using matrix operation. This will not only give you insight to matrix but also tell you how in general it can pave a gateway for three-dimensional reflection. As far as JE is concerned, this will be helpful for those who want to see the matrix version of the coordinate geometry. So let's start with the simplest case. As we know, the reflection of a point in a line is a very extended concept, which simply means, let's say if you have got a point 1 comma 2 and if we are asked to reflect in x-axis, it's going to be 1 comma minus 2 matrix. So here is the philosophy. Let's say we have a general coordinate system xy. We have got a random line y equal to x plus b. Let's say we have a point x comma y with respect to this whole Cartesian coordinate system, and we want to find the reflection x dash comma y dash. As all of you know, this can be done by just using distance formula. What I'm going to do is a matrix version of this. So now this problem seems complicated for a general line ax plus b. Moreover, this point at x equals 0, we are going to get b 0 comma b. Suppose instead of this problem, if someone asks you to solve this problem, like the reflection of a point in x-axis, so that will be surprisingly easy question. So given a choice, obviously you'll be solving the first one over the second one. Now we are trying to search a way in which we'll convert the given statement, the general problem statement, to a problem of just reflection through x-axis, and this will be achieved with two operators. One is rotation matrix, another is reflection matrix along x-axis. Now when I talk about matrix, let's say if you have a point 1 comma 2, so this is your initial point and we have final point. Usually we represent the initial point with a matrix with a column vector 1 comma 2. So this is your input and your output should be 1 comma minus 2. So can we think of a crazy matrix which will reflect 1 comma 2? So can you think of a crazy matrix which will reflect 1 comma 2 to 1 comma minus 2? It's very obvious and simple. So what input should I keep here so what input should I keep here so that this into this, the matrix multiplication will give 1. So clearly if I'll keep 1 and 0, so you know by multiplying this we'll get 1. To get minus 2, I want 1 to equal, so 0 and minus 1. So this is your reflection matrix along x-axis. Let's call it Rx. Similarly, there is something called rotation matrix. So let's say if we have a point x comma y, and if you rotate this with an angle theta, so we'll get a new point. Now that point we can write in terms of x and y. One of the way of doing so will be using complex number, although you are free to use basic coordinate geometry and distance formula as well. What I am doing is complex number. Let's say xy makes an angle psi here. So this point can be written as, this complex number can be written as r e to the power I psi, where r is nothing but root over x square plus y square. Hence this point can be written as r e to the power I theta plus psi. Now if you see the coordinate of this, it will be r cos theta plus psi, comma r sin theta plus psi. And now you can clearly see basically x is nothing but r cos psi and y is r sin psi. So r cos psi we can write as x, so that becomes x cos theta, minus r sin psi is y, so y sin theta, and we have r cos psi is x, so x sin theta, and plus y cos theta. So you can see the final x dash y dash after rotation through an angle theta comes in this form. Now this format can be written in a very cool way, which goes like this. If we have got x and y, so x coordinate we can retrieve the information by multiplying with cos theta minus sin theta in the matrix format. And now we want x sin theta and cos, so here I'll put sin theta and cos theta. And you can convince yourself, once you multiply this into this becomes the x coordinate, this into this becomes y coordinate. So this is our new coordinate, x dash y dash. And this matrix we will call it rotation matrix R theta. So what is rotation matrix? It takes up a point x comma y and rotate it in anti-clockwise sense by an angle of theta, preserving the length of it, right? So these lengths are equal, and that will be given by x dash y dash. In fact, you can find the other way around. If you were to find what is xy in terms of x dash y dash, basically you can solve this both equation and find xy in terms of x dash, and what we'll get is exactly inverse of this matrix in the language of matrix world. So replace theta with minus theta. So basically now with respect to relative motion, you are going in opposite direction. So it will be cos theta sin theta minus sin theta cos theta, and that is nothing but r theta, this matrix inverse. So coupled with these two basic ideas of rotation and reflection matrix, now we are ready to attack this scenario. So coupled with this, now we are ready to attack this scenario. So coupled with this idea, now we are ready to attack the general scenario of reflection per point in a line using matrix format. And here we go. So the point, the y-intercept is clearly 0, p, because at x equal to 0, y will be b. Now instead of reflecting x, y in the line y equal to x plus b, what we'll do, first we'll shift the entire coordinate points. So each and every point on this line, including points this, so this point, let's say A, and all the points here on the line will be shifted. Let's shift it by b unit down. So if you shift it, if you make it fall by b unit down, the new line will be here. So all the point suffered this change. So basically point x, y also suffered b unit gravitational fall. Okay, so how that can be achieved mathematically? So for the y coordinate, we are basically subtracting b from y coordinate of point. So let's say if we start with any point x, y. So x, y represents point A or each and every point on this line. Okay, y equal to x plus b. So that's a generic point which takes care of that feeling. If I make any point A fall by b unit, so basically the new coordinate will be same x, but y will become y minus b. So in matrix form, actually we can add 0, minus b to it. So that's a way of telling the field like, so that's the way of capturing the information of gravitational fall by b unit. Now, so finally we have point over here. Now if we rotate this point, let's rotate this point by theta angle. Now what theta I'll choose? I will choose theta as an angle that this line makes with x-axis. So with that theta, if I rotate, so this point is going to be somewhere. Let's say it comes here now. This is a dash and it's a double dash. Accordingly, the line has also exactly become the x-axis, right? So simultaneously, the point A is suffering a change and line is also suffering a change simultaneously. So point is going to a double dash by rotating with r theta. So I'm rotating by this matrix r theta, which is cos theta sin theta, and that rotation matrix, this one. Okay, by definition, I've defined r theta as cos sine minus sine and cos. Now once we have rotated, we know now we have a new line and a new point a double dash. Now reflection of a double dash in that new line is already known to us. So in the final answer, now just we have to reflect it along x-axis. So let's pre-multiply with rx. So whatever point we are getting, this represents a double dash. Now we are reflecting rx. So that's the answer for reflection along x-axis. Okay, so till 1 we have a triple dash. Now how to restore to the point, reflection point of this a reflection? We'll reverse the phenomena. So first we'll again go by the now. So this was your clockwise direction movement. So it will not be r theta, rather it will be r theta inverse, right? Now we'll reverse the same process. So after a triple dash, we'll go in a clockwise, anti-clockwise direction. So that will be multiplied with r theta and now we'll shift it by the same unit 0 comma b. So this will give you a final answer x dash comma y dash, which is a reflection of a point xy in that line. What's important to note is, like, this looks too clumsy, but it's exactly the operation which matrix does. So let me recapitulate again. So we have x comma y, that added with 0 comma minus b makes gravitational fall, that multiply with r theta inverse is basically, this is your r theta inverse, is clockwise direction movement of this line. This was done to make it x-axis. This is done so as line passes through origin. Now we multiply with an operator rx, which picks up any point xy here. So this will give some point, right? X nu, y nu, that is reflected in x-axis. Once it's reflected, we got the answer, but now we have to retract the answer. So we'll reverse this step. So reflect it back, rotate it back. So once we have rotated, now we have to move by 0 times b unit, and that will give you the answer x dash comma y dash. So this was surprisingly beautiful result. What J can ask you is, they can define, you know, like x dash y dash as this, where r theta and rx will be defined according to the matrix. So let's say if I define r theta as cos theta sin theta and minus sin theta cos theta, and rx is defined to be 1 0 and 0 minus 1. So let's say r theta, if I define like this, and rx is defined like this, and if I ask you, like, give the reflection of a point or find x dash y dash for a given value of theta and given. So if r theta and rx is given, if you're asked to calculate this entire operation to be 1 and theta is pi by 4. So in that case, you will be asked to calculate the output of the function, let's say of 1 comma 2. So you know, this problem basically boils down to b equals 1 means intercept 1, theta pi by 4 means angle is pi by 4. So equation of line is y equal to x plus 1. So basically the questions boil down to the output x dash y dash is nothing but reflection of 1 comma 2 in the line y equal to x plus 1, right? Let's say for b equals 0 and theta equals pi by 4, they give the input point xy as 2023 and 2024, and you are asked to calculate x dash y dash. So you know, it's nothing but a reflection of b equals 0 means passing through origin. So this line will be y equals x. So reflection of 2023 comma 2024, which I always feel like doing this. So if we have got a, this can be proved in a very exciting way. Let's say if you have apartment like this, so this is your apartment. If you reflect this in y equal to x, it will just become vertical. Okay, so what was, so let's say this coordinate was run and rise. So what was run comma rise will become rise comma run. Okay, because now this distance has become this y coordinate, and the y coordinate became x coordinate. So fundamentally this L shape became L shape inverted. Okay, so hence coordinate gets changed, x change in y equal to x. Anyway, I hope you enjoyed, and the takeaway was how